So in this case, we are going to consider as a continuation and working with our examples so that we can see how to attempt these typical questions. As I talked about, guys, calculations of the axial force from the diagrams that I was presenting, the number of contact pairs, moving on to the angular velocity, which we said is an important part of this angular velocity as it states the final angular velocity must be the same for the two shafts when we have this part of the slip where we're going to talk about the slippage and we calculate the time or to calculate the total time of slip actually that is going to be needed. And also considering other calculations. Remember, we managed to talk about these calculation of the mean radius to the power, which can help us to obtain the torque at the end. So that is our major part, guys, to use these formulas only so that we just understand, guys, the basics. Then we're going to have other formulas later on. But for now, that's it. All right. So the first question that we are given here is that a clutch with 4 contact surfaces. So we are given number of contact surfaces, in this case, n, which is 4. The number of pair surfaces is required to transmit 300 kilowatts. That is the power, 300 kilowatts. And also we are given at this speed when it is transmitting at that speed. So meaning to say at this speed of 250 revs per minute, that is where we obtained this power. So definitely, guys, we do understand there is no way, guys, power, speed, and the torque, they go hand in hand. We saw from our formula. So there's something there about our torque. Anyways, let us move on. Then we are given the inner radius is 65 millimeters. So divide by 1000 or multiply by 10 to the exponent of -3. So this is the inner radius. Remember from our concept, guys, we have the inner radius and also we have got the outer radius from this condition of the annulus. So the inner radius, so if you multiply this, guys, converting to meters, it was going to be 0.065 in meters. So the mean radius, 120 millimeters. So remember RM, mean radius, divide by 1000, that's 0.12 in meters. All right. Another part is the uniform pressure on the what? On the contact surfaces. Remember that pressure is uniform of 190 kilopascal. And the coefficient of friction is, meaning to say there's a friction to be considered once there's a coefficient of what? Of friction. So the question was, calculate the outer diameter. So remember, the inner diameter is going to be small letter d. So we need to know the outer diameter. That is our question here. This is our question. So how can we attempt this? How can we have our outer diameter? If we have the inner diameter, it will be easier for us. Remember, I say this. I mean, if we have that outer radius, it will be easier because we simply have to multiply by 2. We've got the outer diameter. So if, let's say, it is there, we're simply going to multiply that one by 2. But as we can see, we do not have that outer radius. So, guys, engineering is all about fault finding. So fault finding in calculations, it's all about going through the formulas and see what you need to calculate and what is that part, the formula that is that part. The radius, as we can see, we could have, yes, used this formula direct. As we can see there, we have it. Or we can just work with this one where the radius is, since we are already given the other part with the radius. So as we can see from this formula, it was going to be up to you guys manipulating, making that radius the subject of the formula, because that is where we have the radius so far. Is there any part that we have it? No. This one is the mean radius. We do not have the outer one. Any other part that we have there, we do not have. The only part that is there is on our axial force. So let's say we have this formula. Let's say this is the one that we want to use, because I want to teach you guys how the fault finding part of our engineering. So from the axial force, it is stating that it is pressure times area. But because definitely, guys, where we've got the inner radius and the outer radius, our area is given by what? Pi r squared minus r squared. Inner, the outer minus the inner. So that was going to be our formula at the end. Pressure times pi r squared minus r squared, of which we can make this one the subject of the formula. It's possible, guys. From our mathematics, it's possible. Let's say we want to make that one the subject. Another part that we can have, I want you to go through your mathematics N3 for change of subject. So what can we do? We can divide by these two. So it's going to be FA over P times what? Times pi, which is equal to r squared minus r squared. So we're going to take this one to the other side so that it's going to be positive there. The moment it crosses the equal sign, it becomes a positive. So it was going to be like this. Remember here, we already have our FA. This is pressure times pi. So if we take this to the other side, it was going to be positive r squared, which is equal to r squared. So definitely, you are going to introduce the square root from there to have our r. So therefore, the formula that we're going to use was going to be r is equal to the square root of what? FA over this. So that's our axial force over pressure times pi plus what? Plus r squared, which is the inner radius. So this, guys, is just a matter of playing with our mathematics. Let's try, guys. We're also doing mathematics N6, isn't it? So this one is easier for us to play around, change of subject. Yes, you can substitute your values. Let's say they are there. You can just substitute. It is fine as well. I'm going to do that in another class. So let's say we manipulated. I want us to see, according to this, what is it that we are supposed to now determine? FA, do we have that? We do not have our axial force. This one, it is not there. The pressure is there. What about the inner radius? The inner radius is also given. So these two, we have them, guys. All right. We are given the pressure and the inner radius, but we do not have our FA is not there. So this is the formula that FA is. So we cannot say, let's go back to this formula and find FA, because there is no one that radius. It is not there. So definitely this formula was not going to work for us to have this FA that is missing here. We are supposed to go back. Remember I talked about this fault finding. So let's go back to our formulas and see if there is a formula that has got FA, but there's nothing to do with area, because it is going to be missing the radius, because we need that radius. So this is useless for now. So let's go to another formula. Is there anyone where FA is? We are going to notice that on the number of contact pairs, FA is there. It is sitting right there, here. But the question is, where it is sitting there, can we determine it? Because that is the only formula now that FA is. We cannot have any other part here. That is the only part. So we have to make sure, that we win from this one. All right. So let's take our formula, because we saw that the number of contact surfaces, they're there. The pair surface is there. Number of contact surfaces. So you have to ask yourself, why is that they give you this value? It means it can play a role. So that means we're going to play around until we have our FA. We need to have this to determine FA. So from number of contact surfaces n, we saw that it is equivalent to torque over what? So that is torque over the coefficient of friction. All right. So that is times Fa times Rm, the mean radius. So this is the one that we need here, the Fa, which is the one that we need. So let us make it the subject, guys. As we can see, you are going to cross multiply because this is over 1. So you're going to cross multiply, then divide, because here this one. All right, let me do it. N times coefficient of friction, FARM, like this, is equal to 1 times T, which is T. So as we need this FA, so we're going to divide by N, this and this. So our FA at the end was going to be given as torque over what? That's N coefficient of friction times what? Times Rm. So guys, I'm going to add this formula, guys, as part of FA, because as you can see, FA is always important in our calculations. So I'm going to add it from that part here. So therefore, as we manipulated here, we can say that at the end, FA is equal to what? The torque. Sorry, that is the torque over what? Over the coefficient of friction. That's the number. Let's start with the number first. The number of contact surfaces times the coefficient of friction, this one, times Rm. This is what we saw, guys, when we manipulated and made the subject of the formula. So that is going to give us our axial force in what? In newtons. So we can add it as part of our formulas, guys. As we can see, we can add that one. So into this formula again, we can see that we do not have T. Rm, we are given everything, these ones, they are there, but we do not have T. So that is where here I was talking about this here to say they cannot just give us this power and the speed and not expect to have torque. So if you are someone under exam, once you see this, calculate the torque from the given information. Calculate what? Your torque from there. So guys, this one I'm not going to waste my time, because in our previous class, we talked about this formula from power and also how to manipulate to end up with this formula of torque here. So I'm just going to take that one. We already manipulated that one. So let's determine torque. So find torque. So these English words, guys, the way that we pronounce them, guys, I do not know, but I just hope you understand me. All right, so this is it, because we're given our speed in rests per minute. So our torque at the end of the day was going to be 60 times the power. P, the capital letter P is for power, 300 kilo. So this is 300 kilo times 10 to the exponent of 3 over what? 2 pi n times the speed, which is 250 rests per minute. So that was going to give us the torque in Newton meter. So that was going to be what? If we are to simplify this, guys, I want you to just use your calculators direct also. That is, just put a fraction, 60 times 300 times 10 to the exponent of what? Of 3. Everything over 2 times pi times 250, like this. So this is what you're going to have. You can also fix your calculator, guys, to 3 decimal places. Shift, go to the setup, then fix. Then we press 3. That's to 3 decimal places. We've got our answer, as it is 11459,156. So this is what we got in Newton meters. So as we can see, guys, this is the part of our talk that was missing. And as we have it, we bring it back to this formula. That is fault finding in industry. You have to go back to that. There's this part. Okay, I missed it. What about this one? I missed. I go to this one until you solve the problem. So they want you to design. They want you to be designed for that. That is why you see these problems. They are a little bit stage to stage, from this stage to another stage. So do not worry, guys. All right. You have your torque there. Substitute back that we can have our force. So therefore, our force was going to be calculated from here because we've got our torque now 11459, 156. Everything over what? Those number of what? Contact surfaces, the pairs that we are given, which is 4, as we are given there. So that is 4 times the coefficient of friction, which is 0.5. So we have that one, 0.5 times our RM. Do we have that one? Yes, we said we are given. The mean radius in meters, 0.12. So that's our mean radius, 0.12. So that was going to give us the value of the axial force from this presentation that we have. So that is it, guys. So that was going to be 47,746,483 to 3 decimal places. That is it in what? In newtons. So we have the applied, which is our axial force, which was missing here on our formula. Guys, when we're not given the pressure we have, pressure we have, guys, this one. Pressure we have it here. So pressure we have. So it's only the radius that we now need. I mean, it was only the force that was not there. Pressure is there, okay? I said it's there here. So we have that applied force, so you can come back here and find the radius. With the radius, we know that the diameter is what is there. So that's how we play around it, guys. So therefore, let's substitute here our radius, the square root of what? Our FA, which we calculated as it is here. So we're going to substitute our value as it is. So that was 47,746, 483 as it was, guys. All right. Over what? The pressure, this P, which is our pressure, as it is the small letter P there. Our pressure is what? 190 kilo Pascal. So that's 190 times 10 to the exponent of 3, the kilo that we are given there, to get rid of that kilo times 10 to the exponent of 3 times what? Times pi. Plus r squared. This fraction as it is done. We add r squared on its own, the radius, the inner one, this one, the inner radius. So what is our inner radius? 0.065 in meters. So that's 0.065 squared. As we can see, that's r squared like this. So on your calculator, guys, please present this one proper. Let me just show you guys. So it was going to be like this. The square root, then put a fraction there because we've got a fraction here. So that's 47746,483. Everything over what? 190 times 10 to the exponent of 3. All right, so we're going to move aside and multiply to pi. So that's shift. We've got our pi here. Then we have to move this arrow aside until it is here. Then we have to add because we are still under the square root. So the square root is supposed to be moving with you. All right, so that's 0.06. As you can see, the square root is moving with us. 5, then we square it like this. So that's it. We've got our answer there. To 3 decimal places, our calculator is already fixed to 3 decimal places. So that's 0.290. All right. In what? In meters. Read this already. So that 0, guys, we can even ignore it. No problem. So this is it, our radius in meters. So we can even convert back to the millimeters as we are given these values. They were given in what? In millimeters. So writing back in millimeters, we can even have it that way, or you can even just leave your answer in meters as it is. Remember, to convert to millimeters, we must multiply by what? 1,000. Remember, you were dividing before to convert to meters. So this time the opposite. So it means our radius can be given if you multiply by 1,000. All right, no problem. Let's use it at the end, but it was gonna be 290 millimeters. Then the diameter now. No problem. We can even use that one, 2 times radius. So therefore, our diameter is 2 times what? 290 millimeters. So 2 times what? 290. 2 times 290 is going to give us 580. All right. 2 times 290 is 580. So that's 580 in what? In millimeters. If you want in meters, just use this one. You multiply it by 2. You have your diameter. If you want, you can just have your diameter. It was going to be 0.58 in meters. It is up to you. Or you can have it in millimeters like this. So that was the consideration. You see how they play around with us. So imagine you are in exam, guys. There's one question which just need this attempt, just to be attempted like this in exam. One, only one. So you have to know your information, your formulas, play around. It's all about playing around with our formula, manipulating of the formulas, figuring out what is missing in that formula. You are done. So I want us to consider this. Then in our next class, we're going to have more examples using this consideration of our advanced calculations.